All right, integer, modulus division, and typecasting. So this is just a basic reminder of these things. We did go over most of this stuff in class. Typecasting we have to do a little bit more. So this is just what we have done already. We've declared two variables, integers. Num3 is a double. Reassigned here, num1 is 9, and main num2, 2. Okay, and when we do this division here, you know that you get 4.0 and not 4.5 because num1 and num2 are both integers and num3 is a double. So when we output, it still outputs a double, but this integer division automatically makes it not have a remainder. So how do we fix that? Now, we've done down here where we fixed the problem by putting a 0.0 on it. So we could have put a 0.0 on the 9, we could have put a 0.0 on the 2, and that would have made it so that 4.5 shows up. But what happens when it's a variable? And you can't change it here, so it's like it's someone's input, or you have test grades and you want an average decimal test grade, but all the test grades are integers. Well, what we do is we typecast it. We do this. We simply put in parentheses, we put double right next to num1. Now it has to be right next to num1, because num1 is the one that we want. Basically this line right here is the same. So basically what it's doing, it's making 9.0 for num1, but we're still dividing it by 2, which is fine. That will still give us a 4.5 for the problem. We only have to make one of them 0.0. You can make both, it's just overkill. Okay, so that's it. If you, however, did this, okay, it would automatically put it in parentheses. It would do what's in parentheses first, and then make it a double, which is in essence what num3 does. It makes it a double because num3 is a double. So be careful, it does matter where you put the parentheses. So we will be practicing that. Make sure if you want it to be 9.0, that double is right next to num1. Okay, so that's all that this stuff is. So this is in essence what happens up here, and that's it. So if we do 8.0 divided by 2, 8.0 divided by 2, that will give us 4.0 as an answer. It will always have that decimal, and the problem with that is num1, this is an error here. So let me just comment this out. Error. Cannot, we've done this enough, store doubles in ints. We can do this math. This math is fine. If this was num3, it would have been better because it was a double. All right, so I commented this thing out right here so that you can see what happens here. Actually, I'm going to move this down so that you can actually see the output. Okay, we can see what's going to output at num1. So here num2 is an int. That's perfect. Num3 is a double. Okay, fine. Num1 is an integer. So if I'm trying to add a double plus an int, I can't do this. This is bad. So we typecast it. So I'm typecasting num3. So what's going to happen? What's going to be the answer? Make a guess. I know what my guess is. It's not really a guess, mind you. So I'm going to compile it. So let's quickly look at what our outputs should be. So this output should be, because it's going to come up, and I'm not going to comment it out so you can actually see what the answer is. This one was typecasted here, so this should be 4.5. Okay, this one was not typecasted, and num1 is an integer, so this one should just be plain old 4. And this one is typecasted, stored in a double, so it should be the same as the above. This one should be 4.5. Okay, so what we're wondering about is our fourth input down. We're going to make sure those are right. Our fourth input down, what is that one going to be? Oh, maybe it's our fifth. All right, I need some help. Okay, so it's 4.5. I missed an input up on an output up at the top. So our final one our last output here is 3. So what happens when you typecast a double, let me see what output I missed. Oh, I missed this one up here. Sorry, this one should have been 4 also. 4.0. Okay, so what happens here is the moment you put an int onto a double, it forgets the decimal. Just eliminates, we like to say, or truncates the decimal. So this 2.5 is now 2. So num3 is 2. Because, oh, num3 is 2. Because we just made it an int. It doesn't round, which we'd like it to. We do have ways to round, and we'll do that later. So what happens is it just eliminates that 2. I mean that 0.5, makes it 2, and 2 plus 1 is 3, and that's what it outputted, 3. Okay, and then here we have our modulus division. So modulus division, remember, is the remainder. So integer and modulus division generally go together. You can modulus a double, but it's not really recommended. So generally we say integer division, this is modulus, and modulus division only on integers. Okay, you can do it on doubles, but it has a different effect. Oh, and that you might not know about. So we're making our number 123, and so this is just, can you predict the output here? So why don't you give it a try? Take a second. I'm going to comment this stuff out while you do that. All right, what do you think the answers are? So I'm assuming I'm going to have something like a multiple choice question or something. So here, let's run. I'm going to predict. No, I'm not going to predict. Oh, my bad. So we compile. And 3, 2, 1. So the very first one, when you modulus something by 10, it always gives you the final digit. So, or we like to say the ones place. Okay, so it's the remainder. If you're dividing something by 10, you're always going to get the ones place there. Okay, this one, you're modding it by 100. So that means if you have 1, 2, 3, the remainder is just 23. And then you divide that by 10, divide it by 10. They're both integers, so you're just going to wind up getting the 2. We're going to do some practice with this one. The ones place, or in this case, it's the 3. And this one, there was truly at zero need to do modulus 1000, because modulus 1000 gives you 123. It's the remainder when you divide something by 1000. What the heck? And then when you divide it by 100, well, how many 100s are there in 123? There's 1. So this is kind of a way to get your digits out. And there's sometimes we need to cut up or parse up the digits, and modulus division helps us. So we're going to do a little more practice with that. Have a good day.